Hi, welcome to the first online lecture for Math 135. My name is Dr. Mark Branson. I'm the course coordinator for Math 135, so I'm the one who plans the homework and the exams and everything, and now is recording online lectures. So you'll still be interacting with your normal faculty member, but I'll be recording lectures for everyone just to maximize the amount of work that we can do as we go online and deal with all the difficulties that we're going to have getting through this. So we're going to work together. We're going to get through it. We're going to learn Math 135. We're going to do well, and everything's going to be okay. So what I want to do today is talk about expected value. So expected value was supposed to be our last topic before spring break. Because the classes were canceled before spring break, we ended up not teaching this. So it's going to be our first class after spring break, our first class online, and the last topic we cover for exam 2. Okay? So I'm going to tell you a little bit about what expected value is, and then I want to do kind of an illustrative example of kind of how it works. Okay? So expected value is the kind of the most likely outcome of some sort of game or situation where we have some events occurring with some probability and the amount of kind of reward of those events varies in each situation. Okay? So a classic kind of example of expected value is if you play a game, right? So if you play a game, maybe if you do something, you win a certain amount. If you do something else, you win a different amount, or maybe you lose money or something like that. Okay? And so when we talk about expected value and talk about games, we're going to talk about taking the probability of a particular outcome and then the amount that you gain if that particular outcome occurs. Like, so if it's a game, the first probability might be the probability that you win. The second probability might be the probability that you lose. And how much money do you gain if you win? How much money do you lose if you lose? Okay? And so what we're going to do is we're going to take those probabilities and those rewards, we're going to multiply them, and then we're going to add them up. So in terms of the definition of expected value, it looks something like this as far as a formula. So for expected value, it's going to be equal to the probability of event 1 times the reward of event 1 plus the probability of event 2 times the reward of event 2. And you can keep going. If there's a third possible outcome, you might have the probability of event 3 times the reward of event 3. You could have an event 4, and so on and so forth. What's important with expected value is that these need to be all the possibilities. Okay? So all of these probabilities should add up to 1 because this should cover all the possible events that occur. And usually that's going to be pretty straightforward, but it's something you have to be a little bit careful with. Okay? So you're going to take those probabilities times the reward, probability times reward, add them all up, and you'll get the expected value. Okay? And so what the expected value is going to tell you is kind of the average amount that you can expect to win if you play this game a lot of times. Okay? So, for example, if you play a game 100 times and say you win half the time and lose half the time, and you win the same amount and lose the same amount each time, then your expected value is 0, right? Because half the time you won and got, say, $10, half the times you lost and lost $10. And so in the end, you gained 50 times 10, you lost 50 times 10, you ended up with $0 overall on average. Okay? So if the expected value is negative, you expect to lose money by playing a game. If the expected value is positive, you expect to win money by playing the game, on average. Again, in any individual case, you might win or lose, a positive or a negative amount, but on average, you would expect to win or lose the expected value. Okay? Let me show you an example, just a very simple example that kind of illustrates this, where the numbers are pretty simple. And we'll finish up with that. And then in the next lecture, we'll talk about some more examples where things are maybe a little bit more complicated. Okay? So I'm going to erase this because my board is small, and then I'll give you the example I'm talking about. Okay, so we're going to look at a raffle. So a raffle sells 100 tickets. Each ticket costs $5. The winner, the one winner, so at the end of the game, after they've sold these 100 tickets for $5 each, they're going to draw one ticket out for a winner. The one winner gets $200. Okay? So that person paid $5 for a ticket and won $200. Okay? So in that case, you're in pretty good shape. The other 99 people, though, paid $5 and won nothing. Okay? And so what we're going to do is we're going to look at those two different situations. We're going to write up what the probability of winning is and the reward of winning. And then the probability of losing and the reward of losing. Because those are the pieces we need to calculate expected value. So if you think about the probability of winning, there are 100 tickets, one person wins. So the probability of winning is 1 out of 100. Okay? What about the probability of losing? Well, you've still got 100 tickets, right? So your denominator, the number you're choosing out of, is 100. But how many of them lose? Well, the other 99. Okay? So 1 out of 100 is the probability of winning. 99 out of 100 is the probability of losing. And notice that those add up to 1, right? Because those are all the different options. You either win or you lose. There's two different possibilities in this situation. And so those add up to 1. Okay? Now, where this gets the tiniest bit more complicated is in looking at the rewards. And that's because we have to think a little bit carefully about what the reward of winning is or the reward of losing. Okay? So if you think about our winner, yes, they gained $200. Okay? But the reward of winning is not quite $200. Okay? So what we have to do is we have to subtract off the amount that they paid. Because if you think about it, think about this raffle. You go to the fair, wherever they're doing this raffle, and you pay $5 and then you win and they give you $200 at the end. How much more money do you have than you did when you started? You don't have $200 more than when you started. You've got $195 more than when you started. Because when you started out, you paid them that $5. You were $5 in the hole, and then you gained another $200. So the reward of winning is actually $200 minus $5. Right, so $195, because that's how much you gained over where you started. Similarly, for losing, so not only did you not win any money, right? So you won $0, but you actually lost money. You lost $5 from where you started because you paid $5 for that ticket. Okay? And so the reward of losing is negative $5. You've got negative $5 more than when you started. You've got $5 less. Okay? And so we represent these negative rewards as negative numbers, right? So if you lose money, that's a negative reward. Okay? So we've got -5 for the reward of losing, 195 for the reward of winning. Okay? And then what we're going to do for our expected value, which I'm just going to abbreviate that EV because I got a small board here in my home office. So the probability of winning is 1 over 100. We're going to multiply that by the reward of winning, 195. And then the probability of losing is 99 out of 100. And we're going to multiply that by the reward of losing, which is -5. Okay? And so we can do this. I'm going to grab my phone to use as a calculator here. So if we take this and multiply it out, we've got 1 over 100 times 195 plus 99 out of 100 times -5. And we end up getting -3 for our expected value. Okay? And so what that means is that on average, the people who played this game lost $3 apiece. Okay? Now, nobody actually lost $3, right? So if you think about it, you've got two kinds of people in this situation. You've got the one person who won the game, and so they ended up $195 in the positive. And then you've got all these other 99 people who lost $5, who came out $5 below. Okay? But since there's one person who won 195 and 99 who lost 5, on average, overall, the average person lost $3. Okay? And so what that means is that if you played this game over and over and over again, you would, on average, lose $3. And this is reflected in kind of the total amounts you win. So if you look at, you've got 100 tickets, the people who paid, right, 100 tickets at $5 a piece, people overall paid $500 to play this game. The amount won was $200, right? So everybody who played paid in $500. Everybody who won $200 total. And so the people who were running the raffle gained $300, which means the people who were playing the raffle lost $300. And if you take that $300 that those people lost, divided by the 100 people who played, 500 minus 200 divided by 100, or I'm sorry, let's do the amount we won. $200 was won, minus the $500 paid, divided by 100, is -3. That's another way of thinking about expected value. So overall, the people who are playing lost $300. If you average that out over the 100 people who played, that comes out to our expected value of -3. Okay? So that's our first lecture. What I'm going to do next is do a few more problems. I'm going to try and split this up into short videos so you can watch them quickly. And the next video will be another example about expected value.